Alright, this is finally lab 7. The first question we went over in class, the main thing you have to remember here is that when you have Q here, the marginal cost curve is going to cross the average cost curve when the average to cost curve is at the lowest point. So just to make it more realistic here. So here's the average cost curve, and the marginal cost curve is going to cross it at the lowest point. So if that's the case, then we know that we're looking for the lowest point of the average cost curve. So to find that, we need to take a derivative of that, which is 4Q minus 16. Make that equal to 0. So Q in this particular case is going to be equal to 4. And that is the point, or the level of output at which the average cost curve crosses the marginal cost curve. It's the lowest point of the average cost curve. The second one, it says, what is the equation for the marginal cost and what point is minimized? Well, marginal cost is always the derivative of the cost equation, which is, in this case, Q square minus 6Q plus 15. Looks right. And then at what point is minimized, and then the lowest point of the marginal cost curve, you take the derivative of the marginal cost curve and then make that equal to 0. So that's 1.998 minus 6 equal to 0. There's a Q right here. Minus 6 equals 0. So then in this case Q is going to be equal to about 3.003, about 3. Alright, this one we did in class. What is the least combination of least cost input combination required to produce a 40 units of output? Just remember that the ratio of the marginal productivities, marginal productivity of L over MPK has to be equal to the ratio of the prices. So in this particular case, that's going to be equal to K over L equals 4. Means that 4L equals K. And then since we use it for 40, then you have basically 40 equals 4L 0.5 L 0.5. Alright, and then from there you find L, and then you find K. Right. So we've done these problems a bunch of times in class. So in order to save time here, so the video can load quickly, I'm gonna skip the last part here. But you solve for L, and then you plug that into here to find K. This one is actually easier than the first one. You solve the problem. Again, but in this case, K is fixed at 16 units, so you're probably going to end up consuming more output because you're not going to minimize costs anymore. So if K is fixed at 16 units, you're going to be forced to use a combination of K and L that is not optimal and doesn't minimize costs anymore. So in this one, it says the government give you a $1 subsidy. That means that the wage, instead of being $4, the wage now, let's call that wage in part C, is going to be equal to $3. So simply solve the problem again. Instead of using the marginal, using the same equation, MPL over MPK equals W over R, but now W change, so K over L, instead of equal 4, now equals 3. And you solve the problem again and find the new quantities of K and L. You're probably going to use less output than before. Although here Q is equal to 60, it shouldn't really be Q equal to 40. But regardless, the main point is that you know that what you're going to do here is to solve the problem again with a wage of 3. Again, same problem that we've done a bunch of times. So I'm really not going to do this again here because, I mean, you should be able to know this by now how many times we've done it. How would input usage change if output is increased to 240 units? What you do is you solve the problem again with output, instead of being 60 is 240 units. The solution in the graph will look kind of like this. So if this is L and this is K, and first you're going to find a solution that is here with a level of L and then a level of K. And then this is Q equals 60. If output is increased to 240, what's going to happen is that you're going to output, the isoquant is going to shift to the right, and then the combinations of K and L are at, the isocost is not going to change because the prices don't change. So what's going to happen is that the combination of K and L will actually change. So this is L2 and this is K2. That's essentially graphically what happens when you increase your output. Let's do a few of these ones. I mean, this is actually not that difficult stuff. Average fixed cost is the fixed cost divided by output. In this particular case, is be 10 divided by Q, right? Because 10 is the fixed part. Average variable cost is the variable cost divided by output. The variable cost here is 10Q. 10Q divided by Q, that's going to be equal to 10. The marginal cost is the derivative of the cost equation with respect to output. So that's going to be equal to 10. And then the average cost is going to be the summation of average total cost and average fixed cost. And here we have average variable cost, for instance, will be Q squared divided by Q. So it's Q. Marginal cost is going to be equal to 2Q. In this one, average variable cost is going to be equal to 10 minus 4Q plus Q squared. Marginal cost is going to be equal to 10 minus 8Q plus 3Q squared. Right? So this is, we've done this stuff a bunch of times, so with equations are not so hard. As long as you know their formulas, you should be all set. Explain the relationship between the change of the marginal cost curve and the marginal product curve. Well, you know the marginal product of labor is the change in output over the change in labor. And you also know that the marginal cost curve is basically the change in total cost over the change in output. Well, clearly here the lower the productivity of labor, the higher the increase of the total cost for every unit of output. Remember that the total cost is also over the short run is actually the change in variable cost over the change in output, and the change in variable cost when you change labor one by one is really the wage divided by the change in output. And the change in output, like I said here, when you have going one by one, is really, therefore, the wage divided by the marginal product of labor. So that kind of gives you, we've seen this equation before, right? This kind of gives you the relationship between marginal product of labor and marginal costs. The lower the marginal product of labor is, the higher the marginal cost will be, and the higher the marginal product of labor is, the smaller the marginal cost is. So they are inversely related to each other. I don't think you should know. You should worry about number 7. It's a very technical question, and it's not something that you will see in the exam. We went over the couple of production functions. You have used it a bunch of times, so you don't really need to know how to develop the cost curve from the couple of production function. So don't worry about question number 7. Okay, so question number 8 we did in class. So if we wanted to produce 100, how much K and L need to minimize the cost of production? Again, you remember that the equation here will be K over L equals W over R, which is actually 8 over 2, which is 4. So, K equals 4L, and plug that into the equation, yada yada yada. So we've done that a bunch of different times. It's actually not that difficult. The more difficult part of this question is the firms operate in a competitive industry. What are the marginal costs when the firm produces 100 units of output? Well, for this one, you remember to use the equation MC equals the wage over the marginal product of labor. So if you know how to calculate this, let's calculate that here. So the W is 8, and the marginal product of labor is going to be the marginal product of labor we can calculate here. So the marginal product of labor is going to be, where's the equation? Where are we here? All right, so here's the equation. Awesome. Here we go. So the marginal product of labor is going to be the partial derivative of Q with respect to L, which in this particular case is going to be equal to 4K. All right, so if 4K is the amount here, then we know how much 4K equals to. So this is going to be equal to 8 over 4K, and the value of K is whatever value of K we have found in here, right? And then once you find the marginal cost, once you find the marginal cost, then you know that marginal cost equals price. So basically this value that you have here is also equal to the price, right? Now remember that this K here is the K you find in part A, right? Which is the value of K when Q equals 100. This problem we did in class, again, there's nothing different from what we've done before. The firm is actually using capital and labor at a ratio of 1:1, but they really should be using at a ratio of, well, K over L equals 4, capital, I'm using the same numbers, 4, right? So it should be 4L to 1K. So therefore, they're really not minimizing costs here, because they're not using the ratios at this rate, but they're using it at a rate of 1K for 1L, right? So that tells you that they're not minimizing costs anymore. And since capital is actually a lot cheaper than labor, they should probably use a lot more capital than labor in this particular case. So it should increase K and reduce L. Now, the second part here is your next. We also did this one in class. The task is to show that the firm, it wants to continue to spend 100, it could produce more output. Well, the firm is actually spending $100. So now you're thinking, well, how much output you can produce if you spend $100? Basically, that's the question. And you know that the price of labor is still 4, and the price of capital is 1, right? So and you know that if you produce anything, you will produce at a level of 4L equals K. So we know that total cost, so W over L plus R K, the price of capital, is actually equal to the total cost. And we know that total cost is 100, right? So this will be 100 equals 4L plus K. So here we have two equations. There's one here, and there's one here. And we have two unknowns. So all we have to do is to use these two equations to solve for the two unknowns. And then we can plug that in. Once we found the values of K and L, we can plug that into the Q equation for, I think it's 4KL, in order to find the value of Q. So we did this one in class. So again, in the interest of brevity and being able to load this quickly into YouTube, I'm not going to go over this particular answer, the specifics. Again, if the firm's operating the competitive limit, what will be the market price? Remember, you're going to use the formula MC equals W over MPL. That's one. And the second one is that MC equals P. So you should be able, so therefore P is going to be equal to W over MPL. And you should be able to find those values pretty quickly from the equations above. This problem is not any different from the one we've done a million times, so I'm not going to go over it again. Q is equal to 300 here, and instead of being L and K, we have two different inputs. That doesn't changes things very much. This particular problem right here, to find the marginal cost of the 225 page, again, MC equals the price of the input, which in this case will be the price of the variable input, which will be H or P, whichever one you want to assume. Say P of H over the marginal product of H. Another way of finding this, if you it will be simply to calculate the total cost of the 227th page, and then calculate the total cost of the 226th page, and then subtract them from each other. That's the marginal cost. But either way you do it, it's actually okay. This problem again is not different from many problems we've done before. The first part, you need to find out if the company is actually minimizing costs. They would only minimize costs if they're producing at a level when MPL over LPK equals the ratio of the prices, right? The price of men over the price of women. The second one, it tells you determine the cost minimizing ratio of inputs when men receive 40% more than women. But since you notice here, men already are getting 40% more than women, right? The difference between the two prices, men are actually pay 560 minus 4, that's 160, right? So 160 is already 40% more than 4, so men already receive 40% more than 4. So all you need to know is to actually find out the values of women and men that the firm will use, and you can find that using that equation right here, which you actually use in part A. Now part B, part C tells you, given that your answer to part B, what percentage of women does the firm hire? Well, if you answer the question in part A, you'll notice that the firm already is going to hire more women than men. I mean, that makes sense because women actually women are cheaper, and the firms minimizing costs, the firms will hire more women than men. So therefore, the law is telling the company you have to hire more women than men, but the firm already is hiring more women than men, so therefore the law will have no effect over the hiring process because their company is already doing that. I will say in general, don't worry about question number 7. It's actually not that difficult, but it's a little too involved. So let's worry more about question number 13 and 14. I think we're going to do those two, which will probably give you a good idea of the graphical issues. So the isocon, isocost. Question 13 we did in class today. If a firm is minimizing costs, is before the minimum wage kicks in, is probably producing, let's say at this point right here, L1, K1. Now if so let's call that A. Now there's a minimum wage kicks in and the firms continue to minimize costs, they will actually produce somewhere along the, to the left of that point. They will use less labor and less capital. But the problem is that in the short term, they might not be able to replace capital for labor because capital is expensive. In the short term, they might have to continue to produce the same labor. But labor is more expensive, so that means that the company is probably not going to be able to lower the cost. So they're probably going to produce some. Let's get rid of that. Can we do that? All right, let's see what we can do here. Well, the company is actually not going to be able to produce at that point. So let me see what I can do here. So I think there's a way to get rid of this thing. There we go. All right, there we go. All right, so let's do so this is L, this is K. Company produces here, originally using this L and this K. Now the cost of labor goes up. Now the company, if it decides to minimize costs, it will produce using more capital and less labor. But the problem is that the company might not be able to do that because capital is expensive, that they need time in order to do that. So in the short term, they might continue to produce at the point where they're before. They might continue to produce at point A. But if the labor is more expensive, at that point they're not going to be minimizing costs. They're not going to be at a tangent point. All right. So in the long term, the company will go back to B and they will fire some employees. In the short term, the company could potentially continue to produce at A, but they will not be minimizing costs. And finally, this problem is very similar to the one before. Developing economies often argue that the method of production associated by companies in developed countries are inappropriate. They're too capital intensive. Illustrate why use of capital intensive method of production might be inappropriate. Well, the main idea is that in a developing country, the cost of labor is probably going to be very low, meaning that if you have to produce a particular unit of output, say like this, if the cost of labor is actually very low, they should probably produce, right? So they should probably produce somewhere around there. Use a lot of labor and use very little capital. So when it says so this is where they should produce, but it says here that the using very capital-intensive method of production may be inappropriate. This clearly explains that if you use a lot of capital, you're not going to be minimizing costs, because if the cost of labor are really cheap, then the slope of the isocost is probably going to be very flat. And if you use a lot of capital, you're probably not going to be minimizing costs. So that kind of answered this particular question.